Hello, this is Amin Sheikh, and I'll be doing Lab 3. So an introduction to the purpose of the lab. So the purpose is to measure the distance dependence of the magnetic field due to a small bar magnet. Then we'll compare measurements with the on and off axis equations derived from the Biot-Savart law. A quick look at the results is that we determined the value of n to be negative 3.1647, which roughly equates to 3. Some key fundamentals before going further is the Biot-Savart law, which is this equation, the distance dependent of a bar magnet as well. So this is the following equation, which leads to the assumption that the magnetic field weakens as distance increases. And then finally, a more familiar equation, which is the magnetic field of a dipole, which also leads to the assumption that the bar magnet acts as a magnetic dipole. So a quick setup of the experiment is to align the phone with Earth's magnetic field, align the meter stick with the bottom of the phone, determine the location of the phone's magnetometer, and then record data. So after recording my data, I went back to the original formula, and by taking the natural log of both sides, we are able to treat n as a slope. Looking at the graph of the data, we find that the slope is negative 3.1647, which is how we computed the value of n, and that's close to a more familiar value, negative 3, or 3. So doing some calculations to determine mu, or the magnetic. So we treat the bar as acting as a parallel dipole. Thus, we are able to use the parallel dipole's magnitude equation, and by plugging in a known magnetic field magnitude and a known distance, we can isolate mu and then determine it to be 1.97 amps times meters squared. For the off-axis of the experiment, we add a perpendicular component to create an off-axis calculation and experiment with numerous trials. After 3 trials, we determined the average to be the following. So a look at the Grillo script model. I finished the function for the dipole function, and used my calculated value of mu and was able to get a model that looked as expected. So here we have the B parallel, the magnetic field parallel, the off-axis one at 45 degrees, and the perpendicular components. This line you can imagine being pushed into the page, and out of the page. And we calculated the magnetic field of the off-axis with this vector. So what are some sources of error? Interference from magnetic or electronic devices could result in incorrect magnetic field readings. Furthermore, the phone not being perfectly aligned with Earth's magnetic field would also result in incorrect readings, as well as imperfect distance calculations could cause slight variations in the correct data. So, addressing some potential questions. What if I hadn't oriented my experiment to compensate for magnetic north, and I had instead laid out my meter stick at some intermediate angle with respect to Earth's magnetic field? Well, Earth's magnetic field would interfere with the data. Adding or subtracting from the bar's magnetic field, the net magnetic field experienced at the phone due to superposition. What if I were to stick 2 identical magnets together end to end and run the experiment again? How would I expect my measurements to differ? Again, due to superposition, the magnetic field experienced at a point would be the summation of the bar's magnetic fields. Thus, the magnetic field would roughly double from the original calculation. Thank you.